Hello everyone. I'm going to talk about differentiation today. And I'm going to differentiate x squared. Now, we already know that the answer is 2x, but I want to know why. Or, in other words, I want to work it out from first principles. So, one way to calculate a derivative of a function is to calculate its gradient. So if I have x squared here, okay, negative side 2, I'm going to take some arbitrary point, which I'm going to call x, and calculate the value at that point, which is going to be x squared. And then I'm going to go off some distance, and I'm going to call that distance alpha. And then I'm going to calculate the value of my function at that point, and that's going to give me x plus alpha squared. Now to calculate the gradient here, I can calculate the slope between these 2 points, right? And the slope between these 2 points is given as this height here divided by this width here. Or also the difference between this value and this value, this minus that, divided by this minus that. So that's the slope. It's not quite the same as the derivative, but it's close. So to summarize, the slope is the height over the width, which is also x plus alpha squared minus x squared divided by x plus alpha, that's this number here, minus that number here, x, which we can simplify further. So that we're going to call that's x squared. Expanding that, we get then 2x alpha plus alpha squared, and then finally that last term, x squared. And at the bottom, we get alpha. We can simplify that further. Two x plus alpha. That's our equation for the slope between 2 points, x and x plus alpha. Now, like I said before, this is not quite the derivative, but it's looking similar, isn't it? But what we haven't done yet is we haven't made the approximation when this point here gets closer and closer and closer to x. In other words, we haven't said alpha approaches 0. So that's what we're going to do now. And we write that like this. We use this lim manipulator as alpha approaches 0 of the slope, which is of 2x plus alpha. And what this means is simply that we make alpha 0. In this expression, it's very straightforward. This term just disappears, and we end up with 2x. So what I've done is, I've taken this point and I've calculated the slope for it, and I've moved it closer and closer and closer to x until the distance between these two is 0, until alpha equals 0. And my expression for the slope is 2x, and that's the gradient. At any point x. At any x. So it's not just for this particular point here some way along the slope. It's for any x, negative, positive, anywhere you want. So that's why the derivative of x squared is 2x. And this general method of calculating the slope actually works for many other functions. You can find the derivative of x cubed. You can find the derivative of sine. You can find the derivative of x to some arbitrary power. The method is the same, but you'll have to work harder on the expansion over here. Okay, I think that's all. Thanks for listening.